In this video, we are going to be looking at formulas and equations and how you can manipulate those formulas so that you can solve them for a particular variable. And really where we're heading is so that we can use that formula to calculate an answer for something. For example, here's some formulas. So this one, I could manipulate this formula. Notice in this one they have 1, 2, 3 variables. And the way formulas work typically is if you know two of those variables, you can solve for the other one. So here, 3 more variables. If I know those two, I can figure that one out. Here there's 4 in this dilution formula. If I know 3 of them, I could figure out the last one. So that's the way formulas work, and we want to work on a few rules or principles that can help us manipulate the formulas and then solve for a specific variable. So, what our main objective is when we have an equation like this or a formula like this is to get one of the variables on a side, doesn't matter left or right side, but it has to be by itself, and it has to be in the numerator or on the top. So for example here, if I wanted to solve this equation for m, I have to get rid of the g and the h. Here's my equal sign, there's sort of my dividing line. If I want to solve this for m, I have to get rid of the g and the h. Just one thing I have a note here is this little p there isn't an exponent or something, it's just sort of a name that we give. So this is energy and it's potential energy. That's what that p down there would stand for. So the first principle we'll look at is something called the multiplication principle. And it basically says if you multiply something on one side, you can do it on the other side too. And that's really how all the principles work. What you do on one side, you do on the other side. So if I wanted to solve this concentration formula for n, so for instance, they gave me a concentration, they gave me a volume, and they wanted me to figure out how many moles there were. So back to the last slide, I want to get n on a side by itself. Right now this v is in its way. I have to get rid of that. So to get rid of it, I can use the multiplication principle, which says if I have c equals n over v, I could multiply this side over here by a v. Notice it's up in the numerator. And I can do that as long as I multiply this side by a v. Now why would I multiply by a v? Well, because if I have a v on the top and a v on the bottom, that would be a factor of 1 and I can cancel those. So if I have the exact same thing on the top and the bottom, I can cancel them. So on the right side, I'm left with an n. And on the left side, I now have volume times concentration. So now I have solved this equation for n. If I wanted to, I could rewrite that equation as n is equal to c times v, just so that if you like having the variable you're looking for on the left, you can just do a wholesale swap if you want. Here's another one. If I have to solve this one for m, okay, so I want to get m on a side by itself. Notice it's the same as this one here. So I'm going to sort of shorten this up. Well, maybe I'll write the formula down again. So n is equal to m over m. And I want to get rid of this m, the big M, because I want just this little one. So I'll multiply this side by a capital M. As long as I multiply this side by an m, I'm good. On this side, the two m's cancel. So I'm left with mass is equal to moles times molar mass. Notice I rearranged those. I don't know why I did that, but that would be the commutative property of multiplication, that the order that you multiply something in doesn't matter. I guess I'm just familiar with it as n times m, but I could have written it as m times n is equal to m. That would be fine too. Okay, sometimes you need to divide to isolate the variable. So say, for example, in this one, the potential energy formula, if I want to solve for m, that's this one, I want to get rid of these two. So if I want to get rid of them, right now they're being multiplied. Those are all multiply in between. If there's no operation given, I'll have to divide each side by that. So let me write my formula down again. Potential energy is equal to mgh. Now I want to get rid of the g and h, so I'll divide this side by a g and an h. If I do it there, I have to do it over here too. So my formula will wind up looking like this. The gravity and the height will cancel, leaving me with just a mass. And then on the left side, I have potential energy divided by the gravity times the height. If I figure that out, that'll tell me what the mass of an object is. Here's another one. Potential energy, solve for H. Same thing. Here's my formula. Notice I rewrite the formula every time and then I do something to it. So if I'm looking for H, I have to get rid of the M and the G. So I'll divide both sides by an M and a G. On this side they cancel, leaving me with on the right side an H, and on the left side potential energy divided by mass times gravity. That will give me height. Notice the pattern there. Doing patterns and doing things in a systematic way with formulas is very, very valuable. Okay, sometimes we need to apply a couple of principles all sort of at the same time. This one I think we have to do 2 or 3 principles. This one, I think I was wanting to solve for V. So let's try and solve this for V. So I want V on a side by itself. I've got 3 problems. There's an M there, there's a half there, and also this V is squared. I'm going to attack the V squared. I'm going to isolate this part of the thing first. So I'll get rid of the M and the half, and then I'll get this so it's just V by itself. All right, so watch how we do it. So I have kinetic energy is equal to a half times mv squared. First thing that I'll do, and maybe I'll just do them one at a time. Sometimes you can do them together, but often at the start it's nice to do it one at a time. If I have a 2 on the bottom, I can use the multiplication principle. I'll take this whole thing and times it by 2. I'll put the 2 in the front there just so it's close to the half. If I multiply this side by 2, I have to also multiply this side by 2. So what I'm left with is 2 times kinetic energy is equal to the 2 and the half cancel. So on this right side, I just have an mv squared. Okay, now I'm wanting to get v by itself, so I have to lose this m. So I have E2ek is equal to mv squared. So to get rid of this m, we'll use a division property. So I'll divide this side by m, and I can do that as long as I divide this side by m. So now let's take stock of where we're at. We have 2ek over m is equal to v squared. We're awful close. We've done a multiplication principle, division principle. Now the last principle, and we haven't seen this one maybe before, is called the square root principle. And every time you do any one of these principles or manipulate any of these equations, there's always a principle that has to govern it. So this one, to get rid of the squared, we use a square root principle. So I square root this side. If I do that, then the square and the square root cancel out. And so I'll just have a v on the right side. But if I square root this side, I have to square root this side too. Looks a little bit ugly, but that will be my formula. 2 times kinetic energy divided by m. The square root of all that is equal to the velocity. In math, with the square root principle, we'd also say that this has to be positive or negative. And I guess in physics we often do that as well, but well, maybe there's some chemistry too. I guess that's a proper way to do the square root principle, is on this side it could be a positive or a negative. Okay, square root principle. Okay, why don't you try some? Maybe press pause and maybe take these 3 questions and see if you can solve each of them for the particular variable. I'm not going to show you how to do these ones, I'll just give you the answers. Okay, hope you've pressed play. This one, if I want to solve for w, it'll be w is equal to a divided by L. This one, if I have to solve for m1, it'll be m1 is equal to, I'll divide both sides by that v1, so it'll be m2 v2 divided by v1. And lastly, if I wanted to solve for v, ooh, that one looks a little bit mean because v's on the bottom. V can't be on the bottom, so I need to get it on the top. So maybe I'll do this one. I'm going to times both sides by a v, and now it gets cancelled on the bottom here, but now it's on the top over there. So this is what I have. If I want to solve for v, I've got to lose this capital M, so I'll take this equation, divide this side by the capital M, divide this side by the capital M. These cancel. Volume is equal to moles divided by molar mass. So that would be this equation solved for capital V. Notice how when I do this, I don't try and skip a whole lot of steps. I do one thing at a time. If you do that, that'll help you in solving equations. Okay, now let's try some with real numbers. We've just done these three equations, and let's just see now plugging numbers in. So they want us to solve for W. Okay, we already did that. So on the last screen, so W is equal to A divided by L. I put my unknown, the thing I'm looking for on the left here. That's just sort of how I like to do it. But I could have written it the other way too. Is equal to area is 45 meters squared divided by the length is 9 meters. So when I divide those two, I'm going to get 5. Meter squared divided meter. If you use our exponent rules, dividing common bases, subtract, this would just be 5 meters. This one I want to solve for M1. On the screen before, we manipulated the formula, so it looked like this. Then let's plug numbers in. So you first manipulate the formula, then plug numbers in. You can plug numbers in first and then manipulate, but I tend to like manipulating first. So M2 is 4.3 moles per liter times V2 is 22.8 milliliters divided by, I don't know why I put that one up high, V1 is 45.6 milliliters. So here the milliliters cancel, I multiply these two, divided by that one. I'm thinking the answer will be around 2, in between 1 and 3, somewhere like that. I don't have a calculator close to do that, but we've done the hard work already. That's just multiply those two, divided by that one. Lastly, this one, solve for V. On the screen before, we manipulated this formula by multiplying both sides by V to give me Vm is equal to N. These cancel. Divided both sides by M, so I get V is equal to N divided by capital M. Plug in my numbers, N, 0.43 moles, divided by the molarity is 1.0 moles per liter. This is a little awkward here to have a per liter on the bottom. So what you can do is rather than write a per liter down here, you can flip it. It has to go on the other side of a fraction line. And here's a fraction line. So rather than going moles per liter down here, I'll go moles per liter and I'll put my liter up top. Moles cancel, I divide, I'll get 0.43 liters. Okay, hopefully that helps you out with solving questions of that type. Here's two that you can maybe try. And press pause maybe and try these two questions. This last one's looking for the velocity. So try these two and see how you do, and then press play and see if you come up with the right answer. Okay, hopefully you've pressed play. I'll just do the reveal of the answers. That one came out to 1.2. Gee, I didn't put units on that. So it would probably, oh, I didn't give you any units here. Oh, those should have units in them, but for now, we're just looking at the numbers, so hopefully they'll work. Hopefully you got those two. Okay, practice some questions. We've looked at how to manipulate formulas and then how to plug numbers in. Hopefully that helps you. You need to practice that lots because you'll do that lots and lots in both chemistry and physics.